Hi dear friends, good morning to one and all. Dear friends, in the past or in the last part of the video, we have started the discussion about the classification of polymers based upon the various criteria. And if you remember about the last lecture, then we have discussed about the classification of polymers based upon the source of polymer. Dear friends, in this online video lecture, we are going to discuss this polymer in detail with respect to the various concept regarding with the polymers. As far as concerned with the classification of polymers, we have already studied about the classification of polymer based upon the source of polymer, and definitely from that lecture we came to know there are three types of the polymers based upon the source, which are natural polymer, synthetic polymer, and the semi-synthetic polymer. Dear friends, in the last part of the video I have also shown you such or this tree diagram for the classification of polymer, and particularly the four different criteria are used for the classification of polymer. The first one classification is based upon the source of the polymer. What is the source of polymer? That will decide its classification. Again, this classification can be done based upon the structure of polymer, how the structure looks like, then that will also decide the classification. And the next one is the how it gives response to the heat, means on the basis of thermal response we can also classify the polymers. And the last one, what are the physical properties of polymers? This is also the one of the criteria based upon which we can classify the polymer into different types. And already I told you, we have discussed the first classification based upon the source of polymer as natural polymer, synthetic polymer, and the semi-synthetic polymer. Dear friends, in this part of the video, now we are going to discuss about the remaining types of classification based upon the remaining criteria. And definitely the second criteria for the classification of polymer is a structure of polymer. How is the structure of polymer? That structure of polymer can also used to decide the classification, or can be also applied for the classification of polymer into different types. And based upon the structure of polymer, the first type of polymer is called as the linear polymer. How or why it is called as linear polymer, that is also important thing. Actually, in this type of the polymer, the monomeric units are linked together to form the long linear chain. This is very important. If the monomeric units of polymer are linked together, are joined together to form the long chain of polymer, then that polymer is called like the linear polymer. So here in this way or in this type, we are getting the long chain of polymer by large number of monomeric units. Or you can say in this type of the polymer, monomeric units are linked together to form the long linear chain. That's why it is called like the linear polymer. These polymers are well packed, and they are also having high magnitude of intermolecular force of attraction. This is also important. So these are well packed, and these are also having the high magnitude of intermolecular force of attraction. These polymers will also show the high value of their densities and the high value of tensile strength, as well as the high value of their physical constant, particularly melting point. And the example of this type of the polymers are the high density polyethylene, nylon, polyester, PVC, that we call it the polyvinyl chloride, and PAN, that pan in the sense polyacrylonitrile. So these are the examples of linear polymer, because in this polymer all monomeric units are linked together to form the long linear chain. That's why these all are called as linear polymer. If you look at the another type of the polymer based upon the structure, and this type is simply called like the cyclic polymer, or sometimes it is also called as cyclic olefin copolymer. In short, these are called as COC. Dear friends, this type of the polymers are amorphous in nature, and generally it is considered as a new class of polymer. These cyclic polymers are amorphous and the new class of polymer. These are generally used in packaging the films, lenses, vials, displays, and medical. So this is nothing but the use. So in short, these are the amorphous polymers and the new class of polymers, and generally used in the packaging different things. Next type of the polymer based upon the structure is called as branched polymer. Definitely it is one of the type that is based upon the structure. Definitely in this type of the polymer will show the branch type of the structure. So here the polymer in which monomeric units are linked together, joined together from the long chain with some side chain or branches, and these side chains or the branches of different length are responsible for the branched structure of polymer, and that's why these type of the polymers are called as the branched chain polymers. These are highly irregularly packed structures, and these are having the low tensile strength, low density, boiling point, and the melting point with linear polymers. So here if you will compare these polymers with the linear polymer, then these are having the low tensile strength, low density, low physical constant, and than the linear polymer, because linear polymers are closely packed because of their linear structure. But as this polymer is having the side chains, or you can say that is nothing, side branches of different length. That's why they are not too closely packed, and they are having the low value of tensile strength, density, and the physical constant. And the examples of these polymers are low density polyethylene or low density polythene, glycogen, and the starch, because this type of the polymers are having the linear chain as well as side chain. Because for example, if you talk about the starch, then it has 1,4 linkage as well as 1,6 linkage. 1,4 linkage of glucose is responsible for the linear structure, and the 1,6 linkage is responsible for the side chain or branches. Now, if you look at the another type of the polymer based upon the structure, then it will be called as the cross-linked polymer. Actually, in this polymer, the monomeric units are cross-linked together to form the three-dimensional network polymer. So here the cross-link in the sense means, suppose this is the one linear polymer, this is another linear polymer, and there is a cross-linking between these two. So this is called as a cross-linking, and this cross-linking is responsible for what? This cross-linking is responsible for the three-dimensional network polymer. So here this type of the polymers show the three-dimensional network of the polymer, and this type of the polymers are hard, rigid, brittle due to network structure, and the examples of these cross-linked polymers are the bakelite, melamine, formaldehyde resin, etc. So this is the classification based upon the structure of polymer. These are generally linear polymer, then it is a branched polymer, then a cyclic polymer, and the last one is cross-linked polymer. Now dear friends, if we will look at the other criteria for the classification of polymer, then the third criteria for the classification of polymer is the thermal response of polymer. How it gives the response to the heat, then that response can be also used for the classification of polymer. And based upon the thermal response of the polymer, the first type of the polymer is called like the thermoplast. I hope we will be able to divide this with thermo and the plast. So these polymers become softened. Whenever these polymers are heated, it becomes soft, and if these polymers are again cooled, then it becomes hard. So this is the simple, that is soft polymer becomes hard if it is subjected for the heat, and this process is reversible, means if again temperature is increased, then the polymer again becomes soft, and if again temperature is decreased, it becomes again hard. So these polymers become soft when heated and become hardened when cooled. And simultaneous application of the heat and the pressure is required for the fabrication or for the formation of fiber of these polymers. And whenever the temperature is raised, the secondary bonding forces are diminished, so the relative movement of adjacent layer is possible in these types of polymer. And the most linear polymers and those having the branch structure with a flexible chain are thermoplastic, and thermoplastics are very soft and ductile. So this shows the property of ductility also. And the example is nothing, with this PVC pipe, polyvinyl chloride and polystyrene. These are the examples of this polymer. Based upon the thermal response, the second type is called a thermoset. What itself indicates that once they will set, they cannot be remolded here. This is the problem regarding with this type of the polymer. So based upon the thermal response, the second type is called a thermoset. These polymers become soft during their first heating and become permanently hard whenever cooled. So once these polymers are heated, they become soft, but as the temperature decrease, they become permanently hard. It means that on further heating, these polymers cannot become soft. This is the once process by which you can make the soft and you can make it hard only once. So this is the difference between the thermoset and the thermoplast. And this type of the polymer do not soften or do not become soft on subsequent heating or on more heating. They cannot be, that's why they cannot be remolded or reshaped by subsequent heating. And in thermosets, during the first heating, what happens? Covalent cross links are formed between the adjacent molecular chains of the polymer, and thermoset polymers are hardened, stronger and more brittle than with better dimensional stability. And this can not be, this type of the polymers cannot be, here it should be, cannot be recycled, and they do not melt and chemically inert. And the examples of these polymers are, that is thermosets, are vulcanized rubber, another one is epoxide, phenolic, polyesters, resins. These are the example of thermosets. So here it is not possible to recycle, remold this polymer, because once that their temperature decrease, they become permanently hard. This is the main difference between the thermoset and the thermoplast. Dear friends, based upon the another criteria that we call it is physical property. What are the physical properties of polymers? And on the basis of physical property, we can do their classification. We can classify these polymers into different types, and based upon the physical properties, these polymers are divided into different types. And based upon the physical property, the first type of the polymer is called as the elastomer. Dear friends, if you will look at the name of this type, then definitely this word itself indicates elastomer. Word itself indicates, it shows the property of elasticity. That's why this type of the polymers are called the elastomer. And here elastomer can be defined the polymer in which the polymer chains are held by weakest intermolecular forces. So this type of the polymer shows the weak intermolecular forces of attraction, and these forces permits the polymers to be stretched. So this type of the polymers can be stretched because of weak intermolecular forces, and some cross links are introduced between the chains to help the polymers retract to its original position after force is released. It means that whenever the force is applied, these polymers can be stretched, and once the force, that is nothing but, or once the force is released, these polymers will get their original position. And this is simply the property of elasticity, or this is simply the property of elastic rubber. And that's why, as this polymers shows the property of elasticity, that's why this type of the polymers based upon their physical property is called as elastomer. And the example of this polymer is vulcanized rubber, which can be stretched. So it shows the property of elasticity. Dear friends, based upon the physical property, the next type of the polymer is called plastic. Word itself indicates that plastic, very well about the plastic. What is the physical properties of plastics? So these type of the polymers are usually much stronger than the elastomer, and some of these polymers are hard, rigid, stiff, dimensionally stable, while others may be soft or the flexible. So this is important. Means some of these polymers are hard, rigid, stiff, and dimensionally more stable, while the others may be soft as well as flexible. And the example of these plastics, which is the polymer based upon the physical properties, is polyethylene as well as polystyrene. So this is about type of the polymer based upon the physical properties. And next type of the polymer based upon the physical properties is a fiber. We have heard this word many times. What is the fiber? Actually, these polymers are present in many plants and animals also, fiber. So these polymers possesses the high tensile strength and the high value of modulus due to rigidity because of strong intermolecular forces like hydrogen bonding, which is present in the polyamide or which operates in the polyamide. And definitely because of the hydrogen bonding, these fibers or these polymers show the strong intermolecular forces of attraction. Again, this type of the polymers leads to close packing, because as these polymers are having the hydrogen bonding, strong intermolecular forces, that's why they show the close packing of chains and impart the crystalline structure, the crystalline nature. And the example of these fiber polymer is nylon and the terylene. The last and the fourth type of the polymer based upon the physical response is called as the liquid resins. So this liquid resins type of the polymer used as adhesives, sealants, etc. in the liquid form. The example is nothing but like Fevikwik. This is also one of the polymer, and these all types of polymer belong to this class. That is nothing but adhesives, sealants, etc. belongs to this type of the class of the polymer, which is called as liquid resins. And the example of this type of the polymers are epoxy adhesives and the polysulfides sealants. So this is all about the classification of polymers based upon the 4 different criteria, and that criteria are nothing but the source of polymer, then structure of polymer, thermal response of the polymer, and the last criteria is simply the physical properties of polymer. So dear friends, in this way we try to discuss whole classification of polymer based upon the various criteria. There are total 4 criteria that just I already told you, and definitely based upon the 4 criteria we can classify these polymers very well with their respective examples also. So I hope, dear friends, you got a clear idea about the classification of polymer based upon the various or the different criteria. In this way we are also interested to express or to determine the molecular mass of the given polymer. As you know, these are very complex, and the large molecule, definitely their molecular mass will be also higher, will also greater, or it will be also large. And definitely there are particular method by which we will be able to express the molecular mass of the given polymer with that method, and we will be also able to determine the molecular mass of that given polymer. So dear friends, we will resume in the next part of the video to discuss about the molecular mass of given polymer. Thank you very much.